Okay, starting with this graph, y is equal to 2x. This graph is y is equal to 2x minus 4. So I've taken the previous graph and all I've done is just moved this line down by 4 units. So y equals 2x minus 4. And then we can go from here to the modulus of this. So now we have the graph y is equal to the modulus of 2x minus 4. This part of the graph was not reflected. So it has the equation y is equal to 2x minus 4. This side was reflected, and it has the equation y is equal to, and you have to change the signs throughout here on the right hand side to get the equation of this side. So y is equal to minus 2x, which totally makes sense because the gradient here is negative, and the y-intercept before was minus 4, it's now plus 4. So let's say we're trying to solve the equation. The modulus of 2x minus 4 is equal to 8. So from here we have the graph of y is equal to 8, and from the right hand side here we have the graph of y is equal to the modulus of 2x minus 4. This one we already have on our sketch here. This one we're going to do now. Y is equal to 8. That's just a horizontal line going through y equals 8, and the solution here when this is equal to this, well, there's two solutions here and here, so we need the x value for this solution and we need the x value for this solution. So to work out the x coordinate for this point, we know that this line and this line intersect here, so we need to solve these two equations simultaneously. So whenever you're looking for points of intersection between two graphs, it's typically simultaneous equations. So y is equal to 8 and y is equal to 2x minus 4. That means 8 is equal to 2x minus 4, because the y value there is equal to 8 right here. So y is equal to 8. 12 is equal to 2x, x is equal to 6, and if we do the same for the other root, or the other solution there, we have the y value there, which is 8, is equal to minus 2x plus 4, subtracting 4 on each side, and if I divide by minus 2, x is equal to minus 2. So the x coordinate here is 6 and the x coordinate here is minus 2, and these are the two solutions to this equation involving the modulus function. Now there's no real necessity to do the graphs, so to look at the same solution without graphs, 8 is equal to the modulus 2x minus 4. So first of all, write down the equation as you see it without the modulus function. So 8 is equal to 2x minus 4. And then write it again, but change the signs on just one side only. So 8 is equal to, if I change the signs on just one side of the equation, and then solving these as before, with this one you've got 12 is equal to 2x, x is equal to 6, and this one here you've got 4 is equal to minus 2x, x is equal to minus 2. So you've got the same solutions as before, but it's a lot quicker to solve without doing the sketch. Okay, here's another problem. 1 minus 4x, the modulus of that is equal to 7. So writing the equation as it is without the modulus, and then changing the signs on one side, and then solving these, so you get these two solutions. if you have the modulus function on both sides, the method is still the same. So let's write this without the modulus, and then write it again, but change the signs on one side. I've changed the signs on the right hand side. I've left the left hand side exactly as it was, and then you just solve both of these, giving you x equals -4 and x is equal to 2/5. The modulus of x is equal to the modulus of x plus 3. So as before, if we write the equation without the modulus, and then do the same thing but changing the signs on one side. Now clearly from this equation, if you were to subtract x on each side, you would have 0 is equal to 3. That's meaningless. So this equation gives you no solution. This one here, taking the x to the other side, so you've got 2x is equal to -3, so x is equal to -3/2. So there's only one solution for this. If you're wondering why you had no solution from solving these two, have a look at the graphs for y is equal to the modulus of x plus 3 and y equals the modulus of x. Let's work out the individual equations from, well, for all of these 4 lines. Okay, so these are the individual equations for each of these 4 lines. And what are we trying to solve here? You've got y equals x here, and you've got y is equal to x plus 3. There's the y equals x, there's the y is equal to x plus 3, and as you can see, this line here and this line here, they are parallel to each other, they will never meet. That's why there's no solution for this equation.